So hello everyone. Thank you all for joining. Excited to do this session together with you today. Today we're going to talk a bit about like context engineering in the world of context engineering, specifically in the realms of AI SRE. And more specifically on how did we do it here at Commodore, how did we build Cloudia, our AI SRE. But I don't want to give you too much spoilers, so I think we'll just go ahead and start. And I think I'm going to start with introducing myself. So hello, as I said, my name is Asaf Savage. I'm the AI engineering group manager here at Commodore. Previous positions, like I led different R&D organizations. And I think the fun fact about me is that people stay awake for 70% of my talks, which to my opinion is very impressive. And as I said, today we're going to talk a bit about like context engineering, like interesting stuff that we did. What did we do okay? Where did we fail or almost fail? And how did we able to resolve those issues? Cool. The agenda, we'll get to it once we get to it. I don't want to read the list, so we'll just continue. So let's start with the background story. And I think we need to like introduce Commodore for maybe 30 seconds. So what do we do here at Commodore? So Commodore was founded with a mission to help our customers to better manage like Kubernetes. Kubernetes is a very amazing product, highly scalable, highly customized, amazing product, but it brings like a lot of barriers, including like some knowledge barriers. It's not very easy to get on board to it and to understand it, especially when it's not like in your day to day. So Commodore helps to manage, to help our customers manage Kubernetes clusters. And we do it in various ways, in various pillars of observability and visibility over the entire stack. And also like in other pillars such as cost, some RBAC issues, security issues. And like 2 years ago, 3 years ago, we have decided that we want to also be tackling troubleshooting. Our personas, the people who are using Commodore on a daily basis, are mainly like ops teams, SREs, DevOps, and engineers, software engineers, infrastructure engineers, etc. And these guys, they face a lot of issues on their day-to-day, right? That's basically their job, to make sure production is stable and is okay and nothing bad is going on. So we wanted to put that as part of the product, the ability to troubleshoot issues, to troubleshoot infra Kubernetes issues using Commodore. And that was the vision that we put to ourselves. Okay, sounds simple, right? Not so much. So the first thing that we did, we said, right, we don't want to reinvent the wheel. We are not the first people in the world that wants to like troubleshoot Kubernetes issues. So let's see how the world does that, right? How other people in the industry are resolving issues. So we started with a very simple use case. I think it was out of memory. And we looked it up online and we saw like, let's find like, there's probably got to be some runbook or anything like that like will teach you how to do out of memory. And the diagram that you see here is the first one that we found, and it's from like Kubernetes 101 or something like that. So it should be very simple for newbies, and it doesn't look that simple, right? It has so many decision points, so many ways to go either left or right, so many decisions to be made, and so many different outcomes for each. We said, okay, it doesn't look that simple, but we're not dealing with simple stuff. We want to be able to provide something more difficult. And we understand that like the world is problematic, but the mission remained the same. We wanted to be able to provide a product that will help the users, people who maintain and manage workloads on Kubernetes, and to be able to help them with troubleshooting. The issue remained the same. So what did we do? We said, okay, we want to solve all of the issues or help solving all of the issues, but let's start with categorizing the issues. Let's start with creating something simple. For each category, we will create some kind of a deterministic runbook. The runbook will guide that person throughout the issue. And by the end of the runbook, they will be able to say that the issue is resolved, or to the very least, they very much understand the root cause of the issue. So that was the goal. And we wanted to do that in an automated way, meaning that the deterministic runbook would be able to select the path, the decision points in each way, to be able to actively choose which way to go. And in the end of the day, we'll be able to find out what the root cause, the RCA, really is. And one thing that was to our advantage is that we have a lot of users, a lot of customers from different shapes and sizes and colors. We have like very small startups with only like a few dozen people. And we have like the large enterprises with thousands and tens of thousands of people working there that are managing very high scale Kubernetes clusters. So we have all this data set that we can get to know and understand and see how it works, and like see if our solution actually makes sense or not. So we said, okay, we have a good starting point, right? We have the data, we have the will, we want to say about ourselves that we also have the ability, and we started this journey, right? Creating an automatic deterministic runbook that we'd be able to automate the process of root cause analysis. And to this day, we actually have almost 2 million incidents. We said here 1 million. I think it's more sexy, but almost 2 million incident. And we were able to say we started by doing it to categorizing into 6 main categories. And we started with the issues that came up, and we started categorizing them and do more issues that we have collected, which was good, right? You want to have your data as accurate as possible. And we reached out to, yes, as I said, to 1 million incidents. Yes, I like casting powers. And as I said, we have categorized them into 6 different buckets. The buckets are resource exhaustion, image and deployment, config and secret management, cascading failure, storage and persistence, and app versus infra. So these categories are like headlines, but each different category or bucket had within it like sub items or subcategories within it. For example, in resource exhaustion, we saw like kill and memory leaks and CPU limits and other stuff, node issues, so etc. etc. And we understand the problem is much more difficult because there are so many subcategories that could belong to different buckets as well. And the number of categories, what you see here, is only a small subset of the actual number. I think it was like 30 or 40 bullets for each of the category. And we said, okay, our problem is getting harder and harder. How the goal was to create a deterministic runbook for each failure or for each type of failure. And now we're ending up with hundreds of types of failures. So we need to create hundreds of runbooks. We said, okay, let's go for the 80-20. Right, we don't solve let's start with not solving all the problems in the world, but let's start maybe 80% of the issues are only on 20% of the category. So maybe we can only tackle those. So first, the 20% is also a relatively large number. We say hundreds, so it's dozens of subcategories to tackle, which is quite a lot, right? And we understand that we are maybe getting ourselves into like a small pickle. We understand the problem of creating this deterministic runbook. We felt like it's getting harder and harder and further away from us. So what did we learn? So we learned that, as I said, it was very difficult. And even within the same subcategory, let's take kill, for example. So a service started working and it got like out of memory and died. So we understand the way to treat those issues start being somewhat different. And the way to tackle those issues is very much different across different variety of environments. For example, in different teams, sometimes you handle stuff differently, right? One out of memory, you'll be handling it one way. and one out of memory, you'll increase the memory. And another one, you'll just fix an applicational bug. And another out of memory, maybe you can live with it because it's something big and it's only like in dev environment. So the variety of solutions to the same issue also varies. So it's not that I can say I can fix out of memory issues because I have a runbook, right? The context matters in different organizations, in different teams, sometimes in different geolocation, sometimes even the same issue, same resources, same team, just different timings. Maybe on a weekend, I would want to solve it in a very patchy way, just for things to last until like the next workday. And maybe during a workday, I want to solve it better in a more robust, strategic way. So we understand that we started something which we didn't thought at the time, but was very naive, right? Creating some kind of a deterministic runbook. We started as we got deeper and deeper into the issues, into different variety of issues, the different variety of the outcome. We started understanding that it's getting very hard. Also, in different scales of the system, the approaches in which you address those is very, very different because in higher scale, the percentage of likelihood that the change you will be making would be also affecting other services is getting bigger and bigger. And as I said, so we started with the process of understanding the issue, and then we understand that the issue alone is really not enough. The issue must come with a very big context that comes with it. So the next thing we do is understanding that the contextual layer of the underground infrastructure, environment, organizational timing, everything, blah, 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 matters the most. And this would well make the change between uh, uh, okay solution and an amazing solution. And we understand that we need to reduce the noise into something that is more contextualized. So we understood that the contextualized layer is essential here, right? It needs to win. Context is key, right? Context. So the next thing we understand, okay, so context is problematic, right? So we need to treat it well. We need to understand it better. We need to understand what is going on in the environments. But before we go to the solution that we make, I want to show you like some few examples. Let's see if I have 3 examples. Let's see if we can make all of those. But we want to make sure we understand like how the same issue can look the same, but at the end of the day, those are maybe different issues that the root cause is different, and therefore the resolution is different. Let's look at the first issue. So I prepared all of those with Cloud Code. So let's talk about the first use case. So what we see here 2 pods. The first called an application called cache loader. The second is an event processor. Both of them are unkilled out of memory at the same time even. And the cache loader is getting unkilled immediately on startup. So it starts, it's initialized, and then it crashes right away with an kill. So we see here the service requires more memory than we allocated to it, right? So the solution is quite simple, right? If the service, so we either need to rethink of that service, maybe it does need to work under like 128 megabyte, or no. But the immediate fix is to increase the memory. Pretty straightforward, right? Let's talk about the other service, the event processor. And in the case of the event processor, it did run. It was able to initialize successfully, and it did run for 13 seconds, and then it got unkilled. And in the graph, we see a gradual memory leak pattern. So the memory kept, as the service lived for the 13 seconds, you see the memory getting higher and higher until it reached to a point where it got to out of memory, and then it crashed, and then like everyone is said, right? So the fix in this case is not increasing the memory. Increasing the memory is not I wouldn't say it's not a good solution, but it's a bad solution. Why? Because if now you have a slim pod that is getting out of memory, if you'll increase the resources for that pod, you'll get a big pod that gets out of memory. You won't fix the issue. The issue is that the application underneath has some kind of memory leak, and the resolution to that must be an applicational change. So we started with two different issues or two different services with the same, someone that looks like the same issue, two kills, same time, same even kind of pod, and but the root cause of those issues and the resolution of those issues completely varies between one another. So this is one example. Let's continue to the second example. The second example is maybe a bit more interesting because it doesn't include like a very simple one pod versus one pod. Here it's a bit more complicated, not too complicated, but a bit more. Here we talk about several resources. So each scenario, each chain has 3 resources. And in this case, we wanted to amplify that sometimes the resource in which you see the error is not the resource which caused the error. When we do investigation, usually we talk about like 3 entities, right? The one that is causing the error to be seen, creates an issue, it crashes, creates some logs or events or metrics or anything of that nature that makes you aware that there is indeed an error. The second entity is the entity in which is the telling you what the error really is, where you understand. So sometimes you get, for example, crash loop backoff, but the reason is that other service is bombarding it or something like that. So there's the second service, the second entity that tells you where the error is, and the third entity is the entity where you apply the fix on, right? So I can understand there is an issue in service X, the smoking gun is on service Y, and the resolution is on service Z. So that's kind of what we tried to do here. So let's take the first chain. So we have a notification service that calls by HTTP to an order processor, and the order, which notification service is crashing, it calls to an order processor, which is crashing as well, which this calls by TCP to a Redis cache, which is running properly. So let's try to understand what is going on. So the Redis cache has some kind of a selector that called up Redis, which is bad. The correct selector should be up Redis cache and not up Redis. So when the order processor tries to reach a Redis that has Redis cache, it fails, right? Because it's misconfigured, the Redis cache. So the order processor tries to use the right Redis cache, which is configured bad, it crashes, and as a result, the notification service that relies on the order processor crashes as well. So the two services that are configured properly are crashing, and the one service that is misconfigured is actually running. So the resolution here, right, is a misconfiguration, and we need to patch the correct the Redis cache with the correct label, the correct spec, and everyone will be happy. At the second chain, let's look at it this way, is a dashboard API that is crashing, right? Sounds familiar. An ETL worker that is crashing as well, that is calling some data store that is running properly. So as you remember, in the previous scenario, we said like the resolution will be like a misconfiguration. Or in this case, the data store pod returns a malformed JSON. There is an applicational issue with the data store that it returns a bad JSON, a malformed JSON, and we see it here. There is like a comma at the end, and the value is bad. So when we query that service, we get a malformed JSON. The ETL worker can't recover from this malformed JSON, and it crashes. And as a result, the dashboard API that relies on the ETL worker crashes as well. So in this case, no misconfiguration whatsoever, right? It's an application issue that needs to be addressed and needs to be resolved. So same issues, right? We said one issue, one service failing, crashes, relies on another service. That's the reason for his crash. The second service is also crashing due to some issue with the third service that actually runs. So both in that perspective, both issues look the same at hindsight. But then when we dive a bit deeper, not too much deeper, we understand the root cause very much different, and the resolution is not only that it's different, you fix it in different ways. Organization, usually it's even the different people, different teams, different organization within the team, right? Because in one way, you can, in one patch, you'll go to your SRE team, to your ops teams. In other, you'll open a ticket to an engineering, depends on the priority and the severity of the issue and the impact of it. So something that looks pretty much the same, you end up with completely different people, different procedures within the company to address those issues. Let's see if we have time for the third scenario. Yeah, why not? So here we wanted to amplify the like app versus infra. So with two deployments, the first deployment is a metrics API, also like misconfiguration. Its probe is misconfigured to run on a bad port, like 9090 instead of 8080. So the deployment is failed because the application underneath doesn't listen on 9090, only on 8080. So we need to change the port. Pretty straightforward. And the issue is that the liveness probe failed, right? So this is the issue that we're seeing. And the second also liveness probe failed. But in this case, it's not about like misconfiguration or a bad port or anything of that nature. Is that the main thread is causing issues. We get some context deadline, it tries to do something, and we have some issues. The main getting stuck until it gets to a point where it just doesn't listen anymore on that endpoint and crashes everything, and liveness probe fail as well. Okay, so in both cases, we have an issue and we want to fix it. And in one case, it's misconfiguration again. And in the other, right, we need to fix the maintenance issue. We got to put it to engineering to be able to resolve it. So what we see here are three different examples that all, once you see it, they look the same. But once you dig a bit deeper, we understand that those are completely different root cause, different analysis, different way of investigation, and at the end of the day, different resolution, sometimes by different teams. So we understand that we started from going by the issue. We understand that we're in a problem. Understanding only the issue alone is not enough. We need to understand also the context, and we need to understand the way of the investigation and how should we do it. And we understand that the deterministic runbook that we all like prayed for and understand is looked further and further. The divergence level was too high. It was too problematic. One issue didn't resemble like another, and even same issues, same pattern, same everything, at the end of the day caused like different resolutions. And also one thing that worked for us very poorly, once you have a deterministic runbook, and during that way, you come up with a new context, new logs, new events, traces that you just discovered, I don't know, it handles new context very, very poorly. So you might have needed to go to a different direction throughout the investigation if you had known that in advance. So it handles new context very, very poorly. And also, every change to the runbook, let's say we got to a point where we feel pretty comfortable with the runbook, with a specific runbook on a specific case. Once we had to do even a minor change, or in very edge case, go left and not a right, anything like that. So we had to rethink our entire runbook because sometimes it might have changed everything. Maybe this doesn't belong in such a deep stage. Maybe it needs to be in stage 2 or stage 3 of the runbook. So every change was very misleading, and it caused us a lot of like cycles of testing and understanding and re-evaluating the data, etc., etc. As we said, different organizations or teams handle investigation different. And we started to say, we had this kind of practice that we said, okay, it doesn't fall easily under the runbooks, it's probably an edge case. So we marked it as an edge case, and then we had another edge case and another edge case, and then we understand like 80% of the cases are edge cases, so we are doing something wrong, right? So the next question to be asked is, have we failed? It's a good question, right? So it's a summit talk, so we can't say we have failed, but we have learned of things, of how not to do things, right? So let's say, what have we done? What have we done that we are doing to this day? First of all, we thought that I think you all know where this is going on. The name of the summit is AI SRE Summit. So we went to the agentic AI SRE. Why? Okay, we don't say because only like of the buzz and everyone is working with AI. We want to see whether it really matches, whether it really solves the problems that we were facing with the deterministic runbook, and whether it actually fits, whether the glove fits. So let's start with the disadvantages that we had and understand whether or not they apply here. So first is the context. AI is very good with handling context, even large context, not too large, but large context is very good, and it's also really great with doing some maneuvers left and right throughout the investigation with new context appears. So this was, only by that, this was worth the change by its own. Let's continue to the next one. First of all, as we said, different organization handles and investigate issues differently, right? So in this case, it's very great. Each organization that we have can add their own data. It will be injected throughout the investigation and will help to make the resolution much more pinpointed to the specific organization that is working with it. One example, we have one of our customers, which is managing a very complex production environment, thousands and thousands of clusters, very big. All of those like are really robust clusters, and we would spend a lot of the time of the investigation just understanding the connections and the interfaces within those clusters in order to troubleshoot the issues. They were handling so many CRDs, customization that they had on their environments, and we just would spend a lot of time on that. So we created some kind of a blueprint or an MD file that after the discovery writes its own MD files, and the MD file actually describes what is going on in those environments. What are those CRDs? How are they connected? What are the different services that utilize the CRDs? How is the customization in those clusters is being applied? And you do that once, and once you have that, and you maintain it from time to time, even automatically, so the investigation becomes so much smarter, and so the investigation already starts with a lot of knowledge. So once you do the actual investigation, you don't need to spend a lot of time, context, tokens, etc., and just understanding the relationships. So the organizational knowledge that each deterministic handbook had to understand or assume by itself is no longer relevant because we already inject it as part of the investigation today. Also, we said another problem is that every change makes us rethink of the entire runbook. So in this case, if we want to support, for example, in different use cases, let's say, I don't know, we want to support now Redis failures. So I can create a sub-agent that is only expert in solving Redis-related issues, and put that as part of our agentic workflow. In this case, I'm not rechanging or restructuring my entire agentic workflow. I'm only adding another piece. I need to do evaluation that it can mess up the result, but I need to do some evaluation, so I'm not through with that. But the amount of work that it takes us to add a new use case, a new service, a new integration is really, really low. Also, in the other deterministic runbook, we said that evaluation, it was very difficult, and every change makes us rethink everything. So in this case, we have so many evaluation methods The evaluation method, we have some more traditional one, like LLM as a judge, golden scenario or golden dataset, failure playground, etc., etc. Those are failures that we reapply Claudia, our agentic AI is called Claudia. So Claudia runs on them on a routine time and even during build, and we understand that whether we provide the same accuracy, same results over time. And I think one cool evaluation method that we do that I think it's worth adding it to any agentic framework is something called like shadow agents. Every change that we make that we feel is like can make lesser results, what we do is actually we create a version behind the scene. Let's say version 1.0 runs in production. So we create version 1.1. We do push it to production, but our customers are not aware of version 1.0. They only see, not aware of version 1.1. They only see version 1.0. But behind the scene, in shadow mode, we run both. We run 1.0 and 1.1. And then we create an LLM as a judge, an evaluator that doesn't necessarily score each run, but it scores the comparison, like which one was better on different aspects, different categories. And then we let it run for whatever time, number of investigations do we need to keep track. It could be hundreds, it could be thousands, but to the point that we have enough confidence that the change we're introducing will not cause any issues, or we hope it will make the issue even better, the situation better, and will make Claudia more accurate or faster or more efficient. But every change that we make, we run it this way. So we run version 1.0 and 1.1 in the background. Once we gain enough confidence, and this is the screenshot that you see here, you see added 4.9%, etc. Once we feel good enough with the change, we apply it in production, and we have high confidence to know that it will work and it will work properly as we expect. And also, this is more of a state of mind than an actual implementation. But we always ask ourselves, what is our North Star? To be able, like, how do we measure ourselves? How do we measure whether an investigation was successful or not? Whether the resource, the service, the namespace, the deployment, whatever, came back to health? Is this? And we want to say that we were in all the world of agentic AI something. So in this case, like agentic AI SRE, we want to resemble as much as possible to an actual SRE, to a good SRE. So we always compare ourselves. Luckily for us, we have a lot of good SREs here in the company. So we ask ourselves, what would a good SRE do? So when we have some kind of investigation that we sometimes don't know whether, because there are so many issues where the solution is not necessarily a one-way solution. Sometimes it's a matter of an approach. If you have some kind of an issue, whether I solve it short-term or whether I solve it long-term. So in different cases, you'll do different solutions. So we compare ourselves whether a good SRE would do that. And luckily, as I said, we have a good SREs, and they help us a lot with doing the evaluation part. We're doing the LLM as a judge and the comparison. A lot of the rules that we have there today are contributed by our amazing SRE. So this way we know that if we are good enough, that a good SRE would say, I would make the same decision. So we are in a good point, and luckily for us, I think that that's where we are. So as I said, AI SRE here at Commodore is named Claudia. We are very proud of her. She's doing an amazing job. And today she handles so many workloads. We see thousands and thousands of investigations per day. And she is doing it in a very efficient way. Today we have 100% utilization of Claudia. Each one of our customers is utilizing Claudia in some way. And we are expanding our capabilities on a daily basis. We keep adding. So the process, the cumbersome process of adding capabilities to the Deterministic runbook was very hard. And luckily for us today, we're working in a pace like never before. And also, as I said, given the evaluation methods that we have, it's very, very easy to add and introduce like new changes, new stuff. And the world is running so fast, and we feel like it's no longer a nice to have. It's like a mandatory feature to have like high velocity in order to meet the market needs. And we are happy to live in the world where the appetite is so big that we need to work faster and faster, and very interesting times. So we started with a very high level approach. We want to help our customers, right, solve issues in the production environment. And we want them to have the capability of a mega investigator that is capable of understanding so many different issues, integrations, different environments to reach to that end goal of providing a good root cause and remediation, to be able to remediate, not only to do the investigation part, but also do the remediation part, which I didn't talk a lot about in these slides. But as I said, the goal remained the same, right? We want to help. So let's see whether we did it, yes or no. So these are real numbers that you see here. So we had like 32,000 investigation, 12 different agents that were part of those investigation. The average latency was like 77 seconds. But the thing we take the most proud of is our success rate. We were able to pinpoint the exact solution in 99.7% of the investigations that we took out of the 32 something thousands. Investigation. This is something we need to make sure is good and is amazing. So, because in the case of AI SRE, it's not like that we are proposing some how to write a mail or anything of that nature, or we're proposing, and of course, no disrespect to anyone, but we're handling here with very severe, sensitive production environments that we know what happened if these production environments are unstable or even down, even for a few seconds. So we need to make sure our success rate is always aspiring to 100%. We must be aspiring to 100% at all times, and it's not just like a slogan or a catchphrase or anything like that. It's something that we really put ourselves as a target, because if we would do 97%, it sounds like a lot, but it's really not. If out of every 100 investigation, we get it not accurate in 3 of those, it's a problem. We need to make sure that out of 100, we get 100. So right now we're almost 100, but we need to get there. So we are continuing improving Claudia, making her broader and broader, and try to tackle more and more issues. So we are very proud of her. Final thoughts. Do we have the time? Yes, so I'll only put a few minutes on it. So we see today a lot of people, ourselves included, are trying to build, to have this thoughts about whether to build or buy, right? It's true not only for the world of AI SRE, but also for other realms as well. But specifically in the realm of AI SRE, right? An AI agent that is able to triage, like investigate, and at the end of the day, resolve issues on my clusters is very much like appealing, right? We want to get that agent, and then I ask myself whether I need to build or whether I need to buy. So the first thing I would do, if I wouldn't have been working for Corridor, so the first thing I would do is probably I would build it myself. I would create a cloud code. I would connect it to my clusters. I would connect it to my database, of course, with the right permissions, maybe at the beginning only read-only, just to get the hang of it, et cetera, et cetera. And I would definitely, and I think, now I'm talking from my Commodore perspective, I would think in most cases, it would do a decent job. But when you get into the deeper domain issues and the very high scale with a lot of noise, where there are so many issues out there, but there is this one issue that you care about the most, that it's the most problematic for you. There is no other way, right, than going like to take like this high scale production proven AI SRE. I have worked with Cloud Code a lot. I'm still working with Cloud Code a lot. I love it. It's an amazing agent. but the domain expertise here mattered the most. And we started to say to ourselves whether it's only the feeling that we have or something else. So as part of the evaluations that we do, as I said, we score Claudia always. Always we score it, we evaluate it, we see like how she behaves in different scenario. But what I didn't say is we're not only scoring ourselves, comparing to ourselves, we're only also comparing Claudia to the industry. So we have a lot of failures, not generic, but very high variety of failures that we check Claudia on from time to time. And we do it also with other competitors in the market and other agents that rely on other agents. And in this case, we stock these scenarios, and on the left part here, this is Claudia, and on the right part here is someone else. And we understand here that Claudia is doing a phenomenal job. As you can see here, it's not perfect. The red ones here are like whether she was able to autonomously heal the issue, because sometimes she requires a human intervention. But in other competitors, which also have access to write Cloud Code, other agent, Cursor, for example, stuff like that, are not reaching the same accuracy, and their score of doing complex issue of a high scale, noisy environment are lesser. So we feel like Claudia's, the ISRE that we have today, Claudia is doing a phenomenal job working. We still have a way to improve, but the world is very much, I think, in our favor. So that's my thoughts a bit about build versus buy. I think build is not a bad choice to go if the issues that you are facing are like common issues, something very simple. The investigation is not too deep with a very basic environment. I think it's a good way to go. But if you want to go to like ProLig and take it like very complex issue, noisy environment, high grade production environments, there is no other way to go than like a off the shelf like AI story. So this was a bit about context engineering. I was very glad to be here with you today. Thank you all for participating, and I had a blast. Thank you so much. Bye-bye.